Greetings, dear students. This is 2019 examination-based contact session for Mathematics 4, that is BES MAT22. This presentation is meant to help you when you are preparing for your 2019 examinations, whether it's the April, August, or November. We take a brief look at some of the topics that, from experience, students have found challenging working through. And therefore, this is not an exhaustive presentation. It cannot be taken as a substitute for your study guide. Your study guide is still very important. You need to seriously and exhaustively work through your study guide. And also supplement it. Your study guide contains the skeleton. You need to put flesh on that skeleton by working through exercises from either resources that are mentioned in the study guide, or some textbooks that you get your hands on, and they contain topics that are covered in the study guide. Go through it, get as many perspectives on a certain topic as it's possible. It will help you very much when it comes to your examinations and assignments as well. The first topic that we'll look at, and this is in most cases a problematic topic, is on direct and indirect proportions. The direct proportion in most cases is okay because it's direct. But when it comes to the indirect proportion, some people solve it as if they are solving an indirect proportion problem. So we'll just highlight the differences between the two. Now, indirect proportion is also sometimes referred to as the inverse proportion. If you read in some books, they will refer to it as an inverse proportion. We say two quantities are directly proportional to each other if when one quantity increases or decreases, the other quantity will also increase or decrease at the same rate. What does this mean? This means that if one quantity increases, the other one will increase as well at the same rate. And if one decreases, the other one will also decrease at the same rate. So they either both increasing at the same rate or they are decreasing at the same rate. On the other hand, and this is just an example of two quantities that are directly proportional to one another. Fuel consumption of a vehicle and the distance traveled by that particular vehicle. That the far you go, the more fuel the vehicle will consume. Okay, so the longer the distance, the higher the fuel consumption, and these two are either increasing at the same rate or they are decreasing at the same rate. On the other hand, indirect proportion, we say that two quantities are indirectly proportional to one another if when one quantity increases, the other quantity will decrease at the same rate. While when one quantity decreases, the other one will increase at the same rate, which means they are indirect. They are not going in the same direction. When one is going up, the other one will come down, but at the same rate. While if this one comes down, the other one will go up at the same rate. That's why it's called indirect or inverse proportions. So I think we see the difference. Direct, they are going in the same direction. When one goes up, the other one also goes up. When one goes down, the other one will also come down. But for the indirect proportion, we have that when one goes up, the other one will come down, while when this one goes down, this one will go up, but at the same rate in both cases. An example of indirect proportion is, suppose you have a job that you want done. Okay? Now, the time it takes to do that particular job is indirectly proportional to the number of people doing that job. The more the people, the shorter the time. The less the people, the longer the time it will take for them to do that job. So that's indirect proportion. Now, from experience, as I said, most of us don't really have problems with direct proportion, okay, because it's direct. But majority of us experience problems with indirect proportion, and therefore we will look at an example on indirect proportion. The same example that we had in the definition, suppose that it takes 4 men 6 hours to repair a road. How long will it take 8 men to do the job if they work at the same rate? Okay, so 4 men, 6 hours. Now we want the number of hours it will take if we increase the number of men from 4 to 8. How long, how many hours it will take for them to do the job. As I said, from the definition, we already said that the more men you have, the less the time, or the shorter the time. And therefore, if we let T be the time it will take 8 men to do the job, then what we have is that 4 men will take 6 hours on the left-hand side. And therefore, 8 men will take T hours on the right-hand side. And then we just work that one out. We get 24 equals to 8T. And now we need to find the value of T. This is really just solving a linear equation, which means we divide throughout this equation by 8. And what we get is T will be 24 divided by 8. And we get 3 hours. So that is how we work out indirect proportion problems. 4 men for 6 hours, 8 men for T hours, because T is what we want to find, and then you just make T the subject of the formula and you get your 3 hours, which means what? Which means it will take 8 men only 3 hours to do the job. Okay, while for 4 men it would take them 6 hours to repair the road. So that's an indirect proportion. You realize that when we increased the number of men, the number of hours decreased from 6 to 3. Remember, we also talked about that they are increasing or decreasing at the same rate. When you increase from 4 to 8, you have basically doubled the number, which means you've increased it by a factor of 2 or by a rate of 2. And you realize that the time decreased from 6 to 3, and therefore you've also decreased it by a factor of 2, which means you've halved. If you double on one side, you will halve on the other side. So that's the same rate that we are referring to. And the next topic that we want to discuss is on the interest. Interest in the sense that you invest your money in a bank. Then there are two different types of interest that one can earn on your money. Okay, you get your hands on $100. You want to invest in an investment account either with a bank or with Old Mutual or with Trustco Bank or some other bank that you want to invest your money in. Now, simple interest, you have interest that is added to the money. The money that you invest in is called the principal. So it's interest that is earned on the principal that you invest in. So simple interest is interest paid on the original amount that you deposit or that you invest with a bank or some other financial institution. And as such, if we let P be the money that we invest, and we call R the annual interest rate, normally given as a percent. Say, in most cases, you'll find it as 12 or even less, 5.5 or something like that. And of course, T is your investment period, the time that you want to invest your money for. And in most cases, it's measured in years. Then the simple interest is calculated using this formula. Okay, that you have the principal, the money that you put in, multiplied by R, multiplied by T, divided by 100. That's the simple interest, and this is the money, the interest that you will earn on the money that you put in. Now, if we invest $2,000 in an account for 3 years at an annual interest rate of 6%, then the simple interest we will earn will be given by the formula that's above. This might probably be misleading. I'll have to change a little bit, but that balance is not the total balance, but the interest that you will earn, which will then be added to the money that you put in. So what we have is, we have PRT over 100. Our P is 2,000, our R is 6, and our T is 3. We divide that by 100 and we get 360. This is the interest that we will have earned after 3 years. And if you now want to find the total balance in your investment account, you will then have the money that you put in, the 2,000, plus the interest that you've earned, which is 360, and you get your 2,360 after 3 years. That is simple enough. So you basically just calculate the interest, multiplied with the number of years that you are investing, and then you add that to your principal, the money that you invested, and you get the money that will be in your account at the end of the 3 years. That is simple interest. You are only calculating interest on the money that you invested. And then we have what we call compound interest. Compound interest refers to interest earned on the money that you put in, as well as on the interest that you've earned in the previous years. What does this mean? This means that, for example, for your first year, you are earning interest on the money that you put in. But when it comes to the second year, the interest that you earned from the first year will be added to your principal, the money that you invested initially, and then the total will be reinvested at the same interest rate. Which means in the second year, you will not only earn interest on the principal, but also on the interest that you earned in the previous year. So compound interest is the interest earned not only on the principal, the original amount, but also on all interest earned previously. Which means in your third year, you will earn interest on the money that you put in, the interest that you earn in the first year, as well as the interest that you earn in the second year. And in other words, at the end of each year, the interest earned is added to the original amount, and the money is reinvested. That's the definition from your study guide, if you've gone through it. Now, the variables that we defined under simple interest, they are valid here. You have your P, which is your principal. You have your interest rate, R, which we denoted by R, and you have your T, which is the investment period, the time over which you are investing your money. Now, in addition to that, it's also possible that one may choose to not only compound the interest or add interest to your money once a year, one may choose to add it several times in a year. Say twice in a year after every 6 months, or 4 times in a year after every 3 months, or even monthly. Okay, after every month you add your interest, which means in the second month you will already be earning interest not only on the money that you put in, but also in the interest that you earned in the first month. Then the amount at the end of the investment period will be given by this formula. Okay, where, as I said, P is the original amount that you invested, R is the interest rate in percent, T is the investment period, the time over which you are investing your money, and N is the number of times that you are adding interest to your money. Then we obtain that formula there. This formula gives you the balance, not only the interest, but the balance that will be in your account at any given time t. And if we look at the same example that we had above, but then in this case we are looking at compound interest and we are compounding monthly, then the balance in our account after 3 years will be worked out as follows. Compounding monthly means that the compounding is being done 12 times in a year, which means N is equal to 12. And therefore, substituting all this in our formula, we have that the balance that will be in our account at the end of the third year will be 2,393 and 36 cents. Okay. Now, if we compare this, to the money that we had for the simple interest, you realize that compound interest earns you more money than simple interest, because in this case you have simple interest, you have interest only worked out on the money that you put in, but the interest that you earn in the previous year is not being considered for the subsequent years when you are calculating interest. While compound interest, even the money that you earned in previous years will also be considered, because if you earn money in the second year, then it's yours and it's your right to reinvest it. They can't just keep it stagnant there, isn't it? So you realize that for compound interest you will earn a bit more money compared to simple interest, and therefore that is what we have. Okay. Playing around with this formula might also be required, which means you are given the balance, then you are asked to find the time it will take to get that balance. That should also be straightforward. It's really just a matter of making T the subject of the formula. And then the next thing that I want us to talk about is on equations. Okay, solving an equation or finding a solution of an equation. This means that we want to find the value or values of the unknown variables in our equations which satisfies the equation. What does this mean? This means that we want the values of the variables such that if we substitute these values for the variables in the equation, the left and the right hand side of the equal sign must be equal. They must be the same. That's what satisfying an equation means. And this is what solving an equation means. For example, if you look at the equation in this example down here, 5x minus 6 equals to 3x minus 8. What we want is the value of x or values of x, if they are more, such that if you put those values wherever you have x, then the left-hand side and the right-hand side must be equal. That's what it means to say that you want the value which will satisfy the equation. Now, in this case, that's our That's our equation. And now we start by collecting the like terms. We call collecting the like terms, which means you bring all the terms that contain x on one side and all the terms that do not contain x on the other side. So in our case, let's suppose that we want to bring 3x to the left hand side because that's where 5x is, and we want to take 6 to the right hand side because that's where we want to keep all the terms without x, and all the terms with x, we want to keep them on the left hand side. Now, moving 3x from the right hand side to the left hand side, since 3x carries a positive sign in front, we need to subtract 3x from both sides. Remember, when you are dealing with an equation, whatever you do on the left hand side, you must do on the right hand side as well. So we subtract 3x on both sides, and what we get is that. Okay, so we have 5x minus 6 minus 3x on the left hand side, and we have 3x minus 8 minus 3x on both sides. And now what you have on the right hand side is that you have 3x minus 3x, that will give you 0. You are only left with negative 8 on the right hand side. But on the left hand side you have 5x minus 3x, that should give you 2x. So in the end, after subtracting 3x from both sides, we will get 2x minus 6 on the left hand side and negative 8 on the right hand side. Now, we still have a term on the left hand side that does not contain x, isn't it? Which is your negative 6. And we need to move that to the right hand side. Now, negative 6 carries a negative sign, and therefore if you want to move it to the right hand side, we need to add it on both sides. Remember, whatever you do on the left hand side, you must do on the right hand side as well. And therefore we add 6 on both sides of this equation, and what we get is that 2x minus 6 plus 6, while on the right hand side you have negative 8 plus 6. What you get on the left hand side then is that negative 6 plus 6 will give you 0, and you are only left with 2x on the left hand side, while on the right hand side you have negative 8 plus 6, that should give you negative 2. And what is left now is, remember, we want to solve x, which means we want to have x on one side and everything else that's not x on the right hand side. And therefore now we have x multiplied by 2. And if we want to have x on its own, then we need to divide by that 2 throughout the equation. Remember, whatever you do on the left hand side, you must also do on the right hand side as well. So we divide throughout by 2, and what we get is 2 divided by 2, it gives you 1, so you're only left with x on the left hand side, and negative 2 divided by 2, it should give you negative 1. And therefore the value of x is negative 1. If you want to see whether your answer is correct or not, you just need to substitute negative 1 for x in your equation, which means you have 5 multiplied by negative 1 minus 6 equals to 3 multiplied by negative 1 minus 8. What you have on the left hand side is 5 multiplied by negative 1, you have negative 5 minus 6. While on the right hand side you have negative 3 minus 8. And what you have on the left hand side is negative 5 minus 6. This should give you negative 11, and negative 3 minus 8, that should also give you negative 11. And therefore what we have is that the left and the right hand side of our equation are equal, which means x equals to negative 1 is the solution to our equation. We have successfully solved our equation. And all the equations are solved in a similar manner. Okay. Now, you will also find cases where you are asked to solve what we call an inequality. The difference between an inequality and an equation is that for an equation you have an equal sign. for an inequality, we have what we call an inequality sign. Signs of that form, that is a less than sign, or a greater than sign, or a less than or equal to sign, or a greater than or equal to sign. But the idea is the same, that you still want to find values of x for which the inequality is satisfied. Okay, we can take an example quickly of 5x minus 6 less than 3x minus 8. Okay, we want to solve this inequality. The idea is the same. You want to have x on its own, and you want to have all the other terms that do not have x on their own. So we still collect the like terms. We take all the other terms to the right hand side and the other terms to the left hand side, which means in this case what we will have is we'll have 5x minus 3x less than negative 8 plus 6. So the steps are as we did in the previous example for the equation, only the difference is that in this case we have an inequality sign instead of an equal sign. And what we get therefore is that on the left hand side we have 2x less than negative 2, and dividing throughout by 2 we get x is less than negative 1. What does this mean? This means that all the values of x that are less than negative 1, all the values of x that are less than 1 will satisfy this inequality, which means if you take an x that is less than negative 1, say negative 2, and you substitute it in this inequality, you will get that the left hand side will be less than the right hand side. Okay, but if you take a number that is greater than or equal to negative 1, this inequality will not be satisfied. Your left hand side will not be less than the right hand side. So this is what it means. The difference between the two is that for an equation you get one value. If your equation is properly defined, then you'll get one value of x which satisfies your equation. If you have simultaneous equations, then you'll get two values because you have x and y in there. But for an inequality, you get a set of values which satisfy your inequality. Like in this case, you have a set of all the real numbers that are strictly less than negative 1 will satisfy this inequality. So the solution in this case is a set, while the solution in the case of an equation is just a value. So that's the difference between an equation and an inequality. However, the idea of solving is the same. You want to have x on one side and everything else that's not x on the other side of either an equal sign or an inequality sign. And your less than here can just as well be replaced by either less than or equal to, or greater than or equal to, or even greater. Let's just note that for when solving inequalities, if you are multiplying or dividing by anything negative, your inequality will change direction. Your study guide will contain more information on this. Please read up on it. I just wanted to highlight the differences between the two. A difference between an equation and a difference between an inequality. You will perhaps also be given an algebraic expression to simplify. What I've highlighted on this slide, these are called laws of exponents. Laws that must be obeyed when you are dealing with powers. Okay? how do you manipulate powers. For example, in the first one, you have that if you are multiplying two powers with the same base. In this case, if we consider, for example, the first power, x is called the base, m is called the exponent. Okay, so x to the power m, this is the base, and this is called the exponent. And now, if you are multiplying two powers with the same base, then this is the same as having that base and you add the powers. And the same goes with the second one in B. If you are dividing, then you keep the base and then you subtract the power, and all the other laws that must be obeyed when you are dealing with exponents. Please go through those and practice on as many exercises on simplification of algebraic expression as it's possible. Make sure that you obey these laws of exponents. I'm sure they also appear in your study guide somewhere. You just need to look them up. But I just sort of extracted them and projected them on this slide just so that we know what laws must be obeyed when we are dealing with exponents. These are the laws of exponents. The other things that we need to know about algebra, you need to know how to factorize. I believe that's straightforward, and so on. So read thoroughly your study guide and make sure that you can do what is expected. Your study guide in conjunction with the learning outcomes, because the learning outcomes, as I said, they will guide you in with regard to what we expect you to know. Everything that is in the learning outcomes, you must be able to do. And of course, your examinations and your assignments are set based on those outcomes. We examine you on the things that we want you or we expect you to know after having completed the module. This is just a list of some of the topics that you need to consider. You need to be able to write numbers in their standard form. You need to be able to work on your personal income tax. You need to be able to read your municipal services bills. The cash and hire service, if you want a furniture or if you want even a car, you have two options. You either buy it cash or you buy it on a hire purchase, which means you put a deposit and then you start paying monthly. You should be able to work out if I do this on a hire purchase at the end of the time, how much will I have paid compared to if I just buy it cash. You need to be able to work out surface areas and volumes of most solids. Some geometry. You need to be able to work out interior angles of some figures. Factorization, simplifying, and solving in algebra. That's some of the things that I just spoke of now. And I think what I left out is things like sketching graphs or working out bearings and so on. And in conclusion, it's really just a highlight of topics that students typically experience problems with, and we hope that you're not going to encounter problems with these in the future. And as I said, I would keep emphasizing that you work through the whole of the study guide. You do mathematics. We don't study mathematics, we do mathematics. So make sure that whenever you are working through your study guide, you have a pen and a paper. You do as many exercises as it's possible, either through the study guide, as I said, or through textbooks in the library, which carries the topic that we are discussing. And I wish you good luck with your examinations, and all the best.